more. Widesight TV.
Iain, aside from cost, what will be the key drivers for floating wind?
So it's always a very interesting question, that one, Nova. So the key part to make floating wind a success has got to be serial manufacture. The scale of ambition has to be there, and with that is obviously the scale of the project. When you look at what's going to be required for the domestic infrastructure, at the moment we're looking at somewhere in the region of about 50 hectares of available land is currently in play for floating offshore wind. But yet, if aspirations to build out from the 1 gigawatt for 2030 is going to be probably closer to about 16 to 20 gigawatts by the time we get into 2040, and that being the case, we're going to require near 100 to 200 hectares of land. So I think that's perhaps one of the biggest drivers at the moment, that we need to look sensibly and creatively at how we actually get that land space. The second key component to that will be look at production flow and understanding the core competence of each of the ports. So at the moment, as I said, because of the potential lack of available space and capability on ground loadings on the key sites, you're going to have to look at what ports are best placed in order to supply, individual componentry perhaps, but also from load out and final flows. So you're looking at the whole serial manufacture from point of good receipt to componentry going out. So I think until we understand what the process flow, how that is mapped out from cradle to grave, it's going to be one of the biggest challenges that the industry faces. There is lots of opportunity of innovation to come into that, so likes of artificial intelligence, and as well as mapping the production flows through digital twinning. So there is a number of these concepts that are being brought into play, but certainly how we tackle serial manufacture and having the right scale and available land to allow us to do that is perhaps going to be one of the biggest challenges. Steve, anything you want to add to that?
I think you've covered a lot of ground there, but just to add maybe a bit of depth to some of those as well. I think when we talk about the availability of land and the infrastructure, that's a sizable investment, but I think not only needs to be a bit of a step change in the level of investment, but I think it's a step change in mindset as well. We've got a kind of challenging scenario where the very nature of the marine consenting process and the auctions themselves, they just engender competition. And that creates a mindset where people want to keep their ideas and their solutions close to their chest. So if we're going to actually deliver these projects at the scale that's wanted, we need to see widespread collaboration. There's just too many different competing design options out there at the moment, and they can't all be successful. So we've got to see industry focus down on the ones that are most likely to work and are going to be proven in the long term, the ones that will survive the 30 years out in that hostile environment, the ones that lend themselves best as designs to competitive serial manufacture. And of course, we've got to move from that competitive process where people just don't want to talk to each other about their ideas to one where if they don't collaborate and use the same facilities and use common solutions, you're not going to commoditise the product to a point where you can make it truly competitive. And then I think we're not going to get around, in the global competition sense, the issue of cheap labour from overseas. So the only way we can combat that is through innovation. But there's a reluctance for people to spend money to schnow on the innovation, not knowing which projects will be successful, what products will be the ones being developed. So one of the real challenges is how do you create this roadmap from the early stepping stone projects we're starting to see to a serial production environment where people are realistically and openly talking about producing one of these a week. Can you imagine in the 1970s if you looked at an oil rig floating alongside a harbour or a shipyard somewhere and were contemplating building an oil rig a week? People would probably have laughed and thought that's just not doable, but it is very much in the art of the possible, but only with a real change in mindset. So we need to get past the competition, we need to get greater collaboration, we need to standardise on some of our solutions, and we really need to make sure that we invest a lot now, money and time, in real innovations. That might be innovations in design, innovations in the welding technologies, innovations in inspection, and how you maintain these devices offshore in a hostile environment for the next few decades to come. So lots of challenges to overcome. At the hub of them all is people just talking more openly to each other about what those solutions should be.
And just sticking with that supply chain piece, where do you see the weaknesses in the UK supply chain at the moment?
I think one glaring weakness is a lack of capacity. As Iain said, we don't have the infrastructure. We need to invest in more land, more factories. We need to skill people. We've got people who are an ageing population within oil and gas, and they've become very good over the decades at doing one-off projects very well. But it's very different to take the kind of analogy of the car factory where you're putting out a car every few minutes. It's a repetitive task, but really very streamlined. I think people underestimate the level of complexity and competitiveness that goes into streamlining some of these operations to shave literally seconds or minutes off them. And that's what we need to do in the serial production nature for floating wind and generally offshore wind going forward. So we need more innovation, we need a different mindset, we need to develop this whole new breed of workers within the industry that have come from that serial manufacturing sort of background. And we need to just open that to a much wider audience. We need younger people coming into the marketplace. Hopefully the opportunity to do a job with purpose, combating climate change, will make it a more attractive market for young people to come into, and we need much more gender diversity about it as well. It's not that traditional companies like ourselves and other manufacturers don't want to see a better gender balance. It's just at the moment the working environment, the type of work just doesn't attract a lot of ladies to come into, whereas in the cleaner factories of the future with more semi-automated or automated equipment, we should have a much more level playing field, and that should, one, make it easier to find people, but two, make it a much more balanced environment to work in, because where we get better balance and a better section of society involved in the work, we get better thinking power, we get better solutions. So these are some of the things we need to do as well.
Yeah, I think just adding to that, I think perhaps one of the weaknesses that I know Steve and I have spoken about before, the supply chain itself perhaps has lacked an element of sophistication through that lack of collaboration that has existed. We're seeing much better engagement now, and that's supported through the likes of the trade bodies like RUK and the Deep Wind Cluster and the Forth and Tay Cluster, and we're seeing that level of engagement increase, but it's still got more to do. I think businesses have to upskill themselves and have to recognise what is their true value proposition and where they actually sit and reside within the supply chain. And I think once they've established exactly what value they offer into the floating wind supply chain, then they'll derive greater benefits. But at the moment, people are still a little uncertain. Businesses are still a little unsure what floating wind means to them. So I think there has to be a greater pace, and that takes, as we talked earlier about collaboration, being involved in clusters, being involved in consortia helps these learnings and helps understand what the value add is for each of the individual businesses, but certainly through greater clarity over value proposition, not trying to be all things to the whole supply chain. It's actually where do they actually sit within that.
So at industry level, what don't we know enough about?
My dad used to say, "You don't know what you don't know," but I think there is. I mean, we're sitting at the moment in we talk about 1 gigawatt, but yet we're talking about maybe 16 to 20 gigawatts. We just don't know enough about the line of sight, and actually, is the technology going to increase, and the WTGs and the megawatts seem to ramp up. We keep beating what the previous targets were, and technology is moving at such a pace that what might be in the one hand seems sensible. We're talking about 100 to 200 hectares that's required. It might be 400, it might be 50, because we're just not quite sure what the final foundation type will be, if there is actually going to be one. So I think the uncertainty around what the technology type will be is certainly a challenge for where we are just now. But we are seeing some front runners. The demonstration projects and the stepping stone projects have certainly brought that to the fore and are enhancing the learnings. So for every project that we're engaged in as a business, we are having a debrief or speaking openly with the consortia to pull out what the learnings are, and the learnings it's a constant path at the moment. So what don't we know enough about? It's what the technology of the future is going to be. I think is perhaps for me, that's the most uncertainty. Steve, do you have a view on that?
It's an absolutely cracking question. We just don't know what we don't know. I think one of the challenges we've got is if you have a problem that exists at a fixed point in time, you can work towards solving it. The challenge with floating wind is, and generally with the industry, is it's maturing so quickly in terms of the technology, turbine sizes, the scale of some of the projects, the rate of adoption, if you like, that we're trying to put gigawatts into the grid with, that we're not really getting a chance to develop that roadmap from where we are today to an endpoint, because the end point keeps moving away. It's like climbing a hill. It's like proverbially you're almost at the top, and then you see you've got another wee bit to go. So because we can't quite see what the end point is, and it keeps moving away with bigger targets, bigger turbines, etc., it's very hard to understand what the solution is. So if you don't quite know what the question is, very difficult to arrive at a cohesive answer. But I think what we're seeing is there's a plethora of designs out there. Intuitively feel that some are going to have more likelihood of success than others. Some maybe seem quite good in the lab or in the test tank. Are they really going to transition to 30 years of life out in the North Sea and some of the harshest environments? We don't know. So I think there's lots of things we don't know, but one of the potential solutions to that is making sure that for the stepping stones projects and the early stage projects that take place, we do encourage collaboration from all the learnings for that. When you look on paper to build something, you always imagine it being a simpler or an easier task than it is, and it's only when you actually try to do it for real that all the problems that you never thought about come in. And we need to go through that trial and error process, if you like. That's in a way what these early stage projects are for. They're about demonstrating the capability of the design, but they're as much about educating the supply chain into what are the challenges, what works well, what do we need to optimise. Because if we don't get that learning, we won't produce dozens, 100 of these things in a competitive kind of way. So I think there's lots we don't know about how the designs perform, what are the real challenges in production. They're likely to be things maybe we haven't thought of yet. The big obvious things in terms of sort of production automation, higher speeds of production, those sort of things we can envisage and we can come up with solutions for. But as they always say, it's the tiny things you haven't thought of that bite you in the bum. And there will be a lot of those on the way, and all of those in aggregate can be quite a barrier to competitiveness. And you've got to kind of go through that trial run to harvest those and then put those learnings into practice. So I think there's a lot we don't know, and there'll continue to be things for these stepping stone projects that we find out that we've just not thought of. And if we can capture those properly in a catalogue and we can share them, then we've probably got a good chance of actually coming up with some competitive methods at scale. But that's probably the key thing we don't know, is there's so many dimensions to cover, we can't possibly answer them all at this point. Anything else, Ian? What do you think? It's a tough
No, I think you
question.
covered that one there, Steve.
It's a really interesting one, though, and I think you mentioned learnings there. So you mentioned a lot that we don't know, and you mentioned learnings. What we do know, one thing we do know, is that the learnings from oil and gas are going to be really important for the growth of floating wind. So with that, we need to help oil and gas workers transition into renewables, offshore renewables. How are we going to do that?
I think we're seeing the signs of it started. One of the criticisms of the transition so far has been the duplication of training standards and competencies. So somebody coming as an offshore worker from oil and gas would have to retrain in lots of skills. Some will be different skills to the ones they've needed in oil and gas, but many will be duplicated. And as we understand it, we're working towards a point where I think Peter are going to join more closely with Renewable UK, and we're going to see perhaps a better relationship, better balancing of the requirements, which were people-based oil and gas training competency schemes with the GOW schemes that have been needed. And maybe then somebody coming with a lot of offshore experience from oil and gas, maybe they're seen to be credited with 70 or 80% of the skills needed, and it's just the top up they need for the things they don't know in oil and gas. And I think the other thing to do is to give us time. I mean, I think if we're talking about the scale of some of these projects that we're trying to do, it's going to take new factories 3 years to ramp themselves up and become competitive. The equipment in day one is no different to the equipment that will be installed in these facilities in year 3. The thing that will have changed is people's skills, people's capability. And in a world where historically oil and gas would have thought to have deep pockets and could throw money at solving problems, and people went from one very different project to another, the main breed of worker going forward are going to be doing standard maintenance routines on the same range of turbine components from the 3 manufacturers across the next decades. The maintenance on the jackets will be quite similar, and in the manufacturing and production side, it'll be the same serial production skills that will learn and be honed. So that needs time to be done. So I think let's get greater harmony between offshore training regimes for the oil industry versus those for offshore wind. And then as we're getting that, let's just make sure that we give the supply chain enough time. It's a transition for a reason. It's not a cliff edge or an overnight change. So if it's going to be transition, it needs time. So industry, the developers, government shouldn't expect us to jump within a year and get to scale with thousands of people skilled and employed. because that's going to take us a few years to get to. So we need space. Iain, your thoughts?
Yeah, you covered a lot there, Steve, and I think for me, I actually don't see it as much of a problem. I think lots of people talk about the transition of skill sets, and I think realistically, there's a huge talent pool that's there, and actually a lot of the skills are very similar. When we're talking about energy, and we're talking about the sector that requires the same project engineer skills, it requires project management skills, leadership skills. So there's a lot of skills that are actually already there, and in terms of actually transitioning across, I think it will be quite a natural progression as well. That transitioning piece, as the industry is growing, as we know the targets are growing, and the build out, and we just see that with floating wind, the establishment of the ports, the growth of the ports, the manufacturing. I think we're looking at the moment to achieve the 60% local or UK content. We'll actually need to build out an additional 15 manufacturing hubs. Now, these 15 manufacturing hubs themselves are going to drive a greater demand for jobs and skills. So I think what we'll find is those that are already involved in this sector, there will be opportunity for them. I also think in terms of the upskilling, it's not going to be so much an upskilling as perhaps a slight change in job. And if I think of in our own business just now, we have an HSE officer, but that HSE officer is now focused on the health and safety, not so much the environmental, because we've created a new role for a group sustainability officer, and that in itself shows where the opportunity exists. One job is now two jobs because of the focus. So I think there will be I think the transition of skill sets will be quite straightforward, and I think the migration will happen in natural economics, I guess, within business as well. So I don't see it so much a challenge.
Energy. Marine. Energy. Power. Widesight TV.